Hey, welcome back. Semester 2 here, so hopefully you're ready for some learning. We're going to start fresh with Chapter 6, 6.1, Properties of Exponents. This is a part 1. So write some things down as you go and be ready to answer those questions as they come up. Here we go. All right, before we start learning some of the algebra rules, we want to start with just making sure that everybody's on the same page with what is an exponent, right? Hopefully you've seen them before, but we haven't worked with them really at all this year in algebra much yet. So just to make sure we're all still on the same page, if you have some problem like 3 to the power of 4, what that means is it does not mean 3 times 4. The way people go wrong is they say 3 times 4 equals 12. That is not what we're doing here, right? We're not doing multiplication. What that means is it means 3 times itself 4 times. So it would mean 3 times 3 times 3 times 3. You can see there's 4 3's there, right? And then as I go to calculate that out, 3 times 3 is 9. And then 9 times 3 would make 27. And if I do 27 times 3, you might have to do it the long way, but 27 times 3 is going to end up making 81, right? So as we're doing an exponent problem, that's what an exponent is. It's telling you how many times you're going to multiply that base number by itself. So before we move forward, I'm going to have you try 2 just to make sure that you know what we're doing here. So the first one I'm going to have you try is 2 to the power of 3. So go ahead and calculate that out and enter your answer when you're ready. A hint, 2 to the power of 3 is not 6. Not 6. All right, so calculate it out, enter your answer when you're ready. So it'd be 2 times 2 times 2. 2 times 2 is 4. Times 2, hopefully you put 8 as your answer. Second one for us to look at here, I want you to try to calculate out 4 to the power of 4. This is going to be a little trickier. If you want to use a calculator for this, you can, but I want you to do it out the long way. Hint, the answer is not 16. So 4 times itself 4 times. And one way I can think of this that's maybe a little bit more going to be easier to work with is 4 times 4 is 16. And then 4 times 4 is also 16. So I don't necessarily have to go left to right. 16 times 16, if you put that in a calculator or did it out the long way, you're going to get 256 on this one. Hopefully we're on the same page with what an exponent means. You should have done some basic exponent problems like this in your past, but this should hopefully get us all on the same page here. Our first new rule of today is going to be called the zero exponent rule, or the zero rule for exponents. And what the zero rule for exponents says is it says for any non-zero number a, a to the power of 0 is equal to 1. So what that's kind of saying is if you ever raise any number to the power of 0, it's always going to be equal to 1. And that's going to help us throughout the day with our simplifying. So for example 1, I'm going to call it example 1a. If I have 6 to the power of 0, that's going to make 1. If I have negative 7 to the power of 0, that's going to make 1. If I have 157 to the power of 0, that's going to make 1. The only real case where it wouldn't make 1 is 0 to the power of 0. We can't think about that one. So just to make sure you're paying attention here, if we have 2,492 to the power of 0, what is that going to make? Enter your answer when you're ready. Yeah, hopefully you got that. It's going to equal 1. anything to the power of 0 is 1 unless it's 0 to the power of 0. We're not going to think about that because it's any non-zero number a. That's our first rule for the day. Our second new rule for the day is going to be called the rule of negative exponents. What a rule of negative exponents says is for any integer n, remember integer means like whole number. So for any integer n and any non-zero number a, we know that a to the negative n is equal to 1 over a to the power of n. And that one's a little bit weird, but just a couple of like examples of how you might see that, because I think that's the wording that's like in our textbook, but it's a little bit heavy wording. But what that really means is if I have like 4 to the negative 2, I can write that as 1 over 4 to the power of 2, and 4 times 4, so 1 over 16, right? Or if I have something like 3 to the negative 5 over 2 to the negative 3, it's kind of interesting. We think of it as a reciprocal. So if there's something in the bottom with a negative exponent, it's going to move to the top. And if there's something in the top with a negative exponent, it's going to move to the bottom. All right, so it'd be 2 to the 3 over 3 to the 5. The last kind of point about this is it works with x's as well. So if I had letters or something like that, so let's say I had x to the negative 4 over 2 squared y to the negative 3. For this one, I have two of the exponents that are negative, right? I have the negative 4 and the negative 3, and one of the exponents that's a positive, right? The 2. So I'm going to leave that positive as is, right? Positive exponents, I don't move. It's just the negative exponent rule. If it's a negative, then it moves. So x to the negative 4, that's negative. It's in the top, so it's going to move to the bottom and become positive. Y to the negative 3, that's a negative in the bottom. It's going to move to the top and become positive. All right, so those are kind of our two new rules for the day. We have our rule of 0 and our rule of negative exponents. So we're going to kind of keep moving forward. I'm going to add on a few examples that are going to combine our two rules for the day for you to try. So throughout the day, the directions are going to be simplify. So for example 3, we're going to try to simplify 4x to the 0 divided by y to the negative 3. Now I'm going to have to sort out my rule of 0 as well as my negative exponent rule here. Now, one reason why I'm bringing this up is because one of the trickier parts of these types of problems is recognizing that there's 3 parts here. I have my y to the negative 3, I have my x to the 0, and I have my 4, right? And I have to deal with each one of those pieces separately. Now, the trickiest part is realizing that that 4 is actually going to be seen as like 4 to the power of 1, right? Because I don't have an exponent there, but 4 is 4 times itself 1 time. So if there's no exponent ever on a base number, it's always going to be like an invisible 1 there to the power of 1. So 4 to the 1 times x to the 0 over y to the negative 3. Now I'm going to kind of sort these rules out or deal with them one at a time. So I'm going to start by dealing with x to the 0. If I ever have a 0 in the exponent, I always start there first. And x to the 0, I know that's going to be 1. And so 4 to the power of 1 times x to the 0 is 4 times just 1, or 4 to the 1 times x to the 1 over y to the negative 3. And that 4 to the 1 times 1 is just 4 times 1, which is just 4 over y to the negative 3. And that kind of sorts out both my green and my yellow and just leaves me with that blue left to deal with. So 4 over y to the negative 3. Now it's negative, so I know it's going to move to the top, right? So 4, and then it moves to the top, and then it's going to become a positive. So the negative 3 is going to become a positive 3. That's my rule of negative exponents, is I'm going to move it to the other part of the fraction, and if it's negative, it becomes positive. And then there's nothing left in the bottom. So if there's nothing left in the bottom, really there's like an invisible 1, because it would be 1 y to the negative 3, and then when I move to the y to the negative 3, there's just a 1 left there. And then 4y to the 3 divided by 1 is just 4y to the 3. So a little trickier there when we have to combine our different rules together, right? I'm going to call that example 3a, and I want you to try example 3b here in a second. So for example 3b, it's 3 to the negative 2, x to the power of 5, over y to the power of 0. So go ahead and simplify that the best that you can and enter your answer when you're ready. All right, so if we go ahead and work this one out, the first thing I'm going to do is I'm going to notice that 0 in the bottom. So y to the power of 0, anything to the power of 0 is 1. Then once I do that, in the top, I have 1 that is positive and 1 that is negative. So the positive is going to stay, and the negative is going to move. So I'm going to move that 3 to the negative 2 to the bottom. And when I do that, it's going to become a positive 2, right? So that's moving that yellow piece there. So 3 to the power of 2 in the bottom, and then in the top, I have x to the 5. Then my last move is going to be to work out 3 to the power of 2, right? 3 to the power of 2 is not 6. It means 3 times 3. So 3 times 3 is 9. So I'd have x to the power of 5 over 9. All right, last one we're going to be looking at here is a simplified question, 10 x to the 0 over 5 y to the 0. Again, the power of 0 here is a big one and more than the negative exponents rule. So I want you to go ahead and try this one on your own and enter your answer when you are ready. All right, so this one is 2 rules of 0. I have x to the 0 and y to the 0, and both of those end up being 1. So I have 10 times 1 over 5 times 1, and 10 times 1 and 5 times 1 is just going to make 10 over 5. And then we can simplify that 10 divided by 5, making 2. All right, so again, powers of zeros, the reasons why they're valuable is they're going to make problems a lot simpler, a lot quicker, because I can get rid of those exponents entirely. Should be ready to try the big ideas practice for today. Thanks for paying attention, and if you have any questions, just let me know.